For our first example, we know that g of x equals x squared plus 1. Find g prime of a. And now we should know that g prime of a means find the derivative of function g when x equals a. So find the slope of the tangent line of function g when x equals a. So to do that, and using the definition of the derivative, what I'm asking to find is what's the slope of the tangent line, and then I'm going to plug in a for x. There are all different kinds of ways to do this. I could actually choose points a and a plus delta x as my starting x values, or I can just stick with what I had been doing, which was to pick 2 points x comma and x plus delta x comma. So these are my two x values, and again I could have used a and a plus delta x. I'm choosing to use x and x plus delta x. I know that if it's x, then that is x comma f of x, or x squared plus 1. If it's x plus delta x, I know that I'm going to have x plus delta x squared plus 1, because these points are specific to this function. Then I'm going to be finding the slope. So I have y2 minus y1, x plus delta x squared plus 1 minus x squared plus 1. And that is over my delta x, x plus delta x minus x. To make it the derivative, the slope of the tangent line, I need to do the limit as delta x approaches 0. Then I'm going to start working algebra. I know that this is equal to the limit as delta x approaches 0, and then x plus delta x squared is x squared plus 2x delta x plus delta x squared plus 1 minus x squared minus 1 over delta x. Everything that was in my y sub 1, my original function, should be canceling out. So I have an x squared and a negative x squared, a positive 1 and a negative 1. Everything that's left, all three terms, have a delta x, so I can factor the delta x out. And I'm left with a 2x plus a delta x in the numerator. And I have just a delta x in the denominator. I'm going to cancel out my delta x's, reevaluate my limit, and this is just 2x. So this 2x is equal to g prime of x. If I want g prime of a, I know that g prime of a is going to be 2a. Okay, part 2. Find the value of x where the function g has a rate of change. A rate of change is a slope equal to a negative 1/3. Now notice it said find the value. So that's implying at one point. At one point, we're looking at a slope. That's the slope of a tangent line. That's a derivative. So it's saying find a rate of change at one point and figure out when it's equal to negative 1/3. So my rate of change is g prime of x. And I want to know when is that equal to the same as negative 1/3. Well, I know g prime of x is 2x. I want to know when that's equal to negative 1/3. So I have 2x equals negative 1/3. To solve for the x value, I would divide both sides by 2, or you could say multiply by 1/2. It's the same thing. Those cancel out, and I have x equals a negative 1/6. So this would be the x value where the rate of change is equal to negative 1/3. If it had asked for a point, I would actually have to plug my negative 1/6 back up into g of x to figure out what the y value is. So this is the answer they are looking for. If I took it a step further, my point would be negative 1/6, and then I'm going to square my 1/6, so that's 1/36 plus 1. So 1/36 plus 1, but I know I have to add common denominator, so I'm going to make my 1 look like a 36 over 36. And that is a 37 over 36. And that is the point where it is. This is the x value, which is what the problem actually asked for. For the next example, it said find an equation of the line that is tangent to f of x equals x squared and perpendicular to this line right here. So to write an equation of a line, I need a point and a slope. I can get the slope right now. It says it's perpendicular to this line, so I'm going to figure out what the slope of this line is. So I have x plus 2y minus 6 equals 0. And I'm going to solve for y. So I'm going to subtract the x and add the 6. So 2y equals negative x plus 6. I'm going to divide everything by 2. So y equals a negative 1/2 x plus 3. So the slope of this line is negative 1/2, which is not the slope of my line. My line is perpendicular to this line. Perpendicular slopes are the opposite reciprocal or negative reciprocal, so the slope of my line is going to be a positive 2/1 or just 2. So I know the slope is 2. Well, to write the equation of my line, I need the slope, which I have, and a point. And it's tangent to this. So I have a problem. I don't have an x value. If I had an x value, I could plug into the y value. I don't really have either one of those. But I know my slope is 2. I also know that my line is tangent to f of x equals x squared. So I know the slope of my tangent line is equal to 2 because my line is tangent and that's my slope. Well, a slope of a tangent line is the derivative. So I know my derivative is equal to 2. So I need to find the derivative of f of x equals x squared. So I'm going to say my 2 points for finding the derivative are x comma x plus delta x comma. So it's x squared, and x plus delta x, it'll be x plus delta x squared. So I'm going to find the slope, x plus delta x squared minus x squared over my delta x, which is x plus delta x minus x, and I'm going to take the limit as delta x approaches 0. So I work this out, and I have x squared plus 2x delta x plus delta x squared minus an x squared over a delta x, and I'm doing the limit as delta x approaches 0. If you look at this, my x squareds cancel out. Everything that's left has a delta x in it. So that's 2x plus delta x in the numerator and a delta x in the denominator, taking the limit as delta x approaches 0. Well, you can see my delta x's cancel out. I reevaluate my limit, and the slope of my tangent line, which is equal to f prime of x, is equal to 2x. So for this problem, I know that my slope of the tangent line is 2x, and I know the slope of my tangent line is 2, because this line is tangent to it and this is tangent to it. So I could say 2x has to be the same thing as 2, which means the x value, the point where it's actually tangent, is 1. I divide both sides by 2, so I've got my x equals 1. The next thing I have to do is figure out what's the y value to use. So I'm going to take my x value of 1 and I'm going to plug it into my original function. So it's 1 squared. My y value is also 1. So when I write the equation of the line tangent, it'll be y equals a slope of 2, x minus 1 plus 1. The last interesting thing to note here is you'll notice that for our previous problem, the derivative was 2x, and for this problem, the derivative is 2x. Well, the previous equation was f of x equals x squared plus 1, which has the same exact shape as f of x equals x squared. It's just raised up 1. So it should make sense that the derivatives match.